Great. Okay. Welcome to day 3. Welcome to the final day of the conference. Another treat this morning. We have the folks from fairkom who are going to introduce their project, which is live in schools. It's called Schulchat. So please join me in welcoming Lisa, Jan, and Philip.
Okay. So, hi everybody, we are fairkom. We are offering cloud, chat and video conferencing solutions, and today we're going to present the messenger solution Schulchat RLP. Welcome to the presentation. The Schulchat RLP is available as a web client within the browser as well as app for Android and iOS. You can find it in the Google Play and App Store. What's the project context? It's a fork of FluffyChat and Synapse. We use the Flutter framework, which enables us to build applications for multiple platforms out of one code base. As already mentioned, it's a communication platform in the educational sector for elementary up to vocational schools. The target group are teachers, students, parents, and also the school management. The customer is the Department of Education of the German state of Rhineland-Palatinate, or it's called Pädagogisches Landesinstitut Rhineland-Pfalz. Yeah, that's also how where the name comes from. It's Schulchat RLP. We've made a lot of customizations, especially to fit the educational requirements. For example, the address book, the integrity condition, the communication metrics. Also, dealing with an abuse was an issue. Therefore, we've implemented a reporting function and more school features like simplifying the recovery key process, active read receipts, PDF review, and Pulse survey feature, and we're gonna show these customizations in detail, and also the Bildungsportal integration. And another challenge was to make it scalable for up to 500,000 users. So we start with the address book. Here you can see how the address book looks like within the messenger. On top you can see the org. It's like a school. In this case it's IGS Testhausen. And there you can see the groups, teachers, Schulcampus groups, which are like classes, the pupils, the parents, and also more school management. It's like role-based models, and there are multiple roles who can interact with each other. Now I will show the integrity condition. It differs a little bit from the metric specification. So there always has to be one admin in the room. The admin is always the person who creates the room, and we only work with 2 power levels. So the admin is the same as the moderator with a power level of 100, and the participant with a power level of 50. And an admin can set another user or participant as an admin, and this is the difference. One admin can also take the admin rights from the user and set him back to a normal user. And an admin can also leave the room, but only if there is another admin in the room. So we take care that there is always an admin in the room. This is the communication matrix. With the communication matrix, you can define which rules can interact with each other. So when they open a room, you can define which role can find the other role and can write. Each org or each school can configure the communication matrix by themselves. So they can, for example, define if it's allowed that pupils write pupils each other, or if it's not allowed, for example, that the pupil can write a teacher. Here you can see how this can be configured. For example, on the left row, the teacher, and then you have all the other rows, and then you can say, okay, can write or cannot write. The same with the pupils on the right side. Yeah, if a school, for example, says pupils are allowed to write each other or to be alone in a room without a teacher, we had the issue with dealing with abuse. So we've implemented like a reporting function. You can just mark a message which maybe is not compliant, and then you can say, okay, I want to report this message. It takes a screenshot, and you can add some text or why you want to report this message, and then it goes for example, to a trust teacher which handles with it. Here's an example of the active read receipt. Yeah, this is like, you have to imagine that the teachers gives like a piece of paper to the pupils, and the pupils take it with home and give it to the parents. And this is, yeah, that the teacher can say, for example, tomorrow is a very important task, or you have, the pupils have to bring something in school, and then it goes to the parents, and the parents really have to say, like, tick the message, okay, I have read it, I have understand it, and it's clear for me. And the teacher can also look, okay, has everybody accept the message, or has everybody already read the message? Or maybe are there still some persons who haven't given the read receipt? Simplifying the recovery key process was also necessary, because many users, you have to imagine that it also has to work for very young children, and they had problems with saving the recovery key and set up the backup correctly. So we decided to go with the passphrase. When the user first log in and set up the backup or creates the recovery key, they can choose out of 4 questions, and the passphrase is like the answer of the question. And when they log in again, they always see the question as support, and then the answer of this question is the passphrase which secures the key, and the key encrypts the backup or the key storage on the server. Okay, and now I will hand on to Philip.
Hello everyone. So I will continue with the problem user had, that they could not find the PDFs after they saved it on the file storage. So we implemented a previewer for the PDF which can be accessed through the I symbol. And what it does, basically just downloading the PDF and decrypt it on the device. So students don't have the excuse that they couldn't do their homework because they couldn't find it on the device. Maybe this is, Anyway, then we have implemented polls. It was also a requirement, and it follows the MSC 3381 specification, and user can single vote or multi-vote, and you can see the percentage and the participants voted for what option. The underlying IDM is like the Bildungsportal, and this is like a German, like for the educational platform, where they have different other softwares or curriculums, and they have single signed on, and with OIDC we can access the Schulchat RLP with this tile and access it there. And this is the technical background from the Bildungsportal. We have like the One Roster API. One Roster is a specification for schools how to exchange information about students and schools. And we implemented the IDM provisioner, which is interval-based and access the REST API every 15 minutes or few minutes, and gets incremental the user data and the enrollments. And on the other side, the IDM provisioner provisions the users and the rooms to Synapse, and Synapse asks for the address book when an invite is happening, if this user can write this user. And yeah, but I will go more into detail. We get like schools from the one roster API, and we get users, classes, and the enrollments, and we see there is like the date last modified, where we can distinguish where we are in the sync process and can make it incremental. What it does, actually, the provisioning, we use like the one roster ID one-to-one for the matrix user ID. When you invite someone, and we have also the room provisioning. We can create rooms, but there's like the IDM bot, which serves like an sync agent who adds user or kicks user according to the mapping. And how it works: when a user creates a room, we get an empty room server side, and the user invites the group within the address book. Then a joint rule is set, and we set its alias based on the school ID and the group ID. And then Synapse checks the joint rule event, and then the next sync cycle, the IDM bot invites according to the joint rule. This is how it looks. In this case, we have like two groups from the school 1 to 3, the class 5A, and this teacher group from the same school. Now I hand on to Jan.
Is this working? Yeah, sounds good. So, hi, my job is to talk about the boring stuff, which is infrastructure, but boring infrastructure is usually good infrastructure, right? So, you probably heard of Kubernetes, use it, know what it is, right? So, I'm not going to explain too much about it. I'm going to cover some details which we are using ourselves at fairkom. We have a mixed workload, so we have to have a flexible Kubernetes infrastructure, but at RLP it looks slightly different, right? So everyone knows why we use Kubernetes, but we do our own infrastructure. So what this means is we have our servers at Hetzner, we install Debian on top, and then run our own Kubernetes with everything, right? So I'm gonna go into this a bit more later. Just a quick overview of the basics, right? So how Kubernetes works is you have a control plane, which is basically in Quorum. They manage the whole cluster. There's the API server, the scheduler, who takes care where to schedule what, right? The etcd is the stateful database, the only stateful thing there is about the Kubernetes cluster, apart from maybe storage, right? And then on all nodes, like the worker nodes, there's like the kubelet, the kube proxy, which takes care of the service, the container runtime, which is usually something like Cryo or Containerd. Yeah, but this is like boring stuff, as I said. But the cool thing about Kubernetes, we can extend it, right? So depending on the organization you're working with, they're using different Kubernetes extensions. We used like pretty basic stuff like CorDNS. I think everyone's using probably Cilium as well. There can be Calico, but Cilium I think is nicer because of the eBPF support. Of course, there's metrics which you have to plug in yourself, right? Which is usually something like Prometheus or an operator related to that. There's logging, which is like usually nowadays it's OpenTelemetry. Or Grafana Alloy or something. You shouldn't use Promtail anymore. This is deprecated, right? In half a year, you need to migrate anyways. But the really cool thing about Kubernetes, in my opinion, are the operators, right? Because we can use an operator and configure it the way it wants, and it does a lot of stuff for us. For example, we use Ceph extensively, and there's the Rook IO operator, which is a really, really great thing, right? The same with Postgres. There's a nice Postgres operator from Zalando called Acid, I think. And if you ever like work with databases, this comes with all bells and whistles. So we have the Patroni inside the container, and I can easily debug like different databases and rescue burning databases and the stuff you usually know from like normal sysadmin stuff. We use the HashiCorp Vault. We will soon migrate to the OpenBAO, which is a great fork, right? Shout out to OpenBAO if you want to have an alternative to HashiCorp. This is for the secret storage, right? Because otherwise everyone who has the access to Kubernetes cluster also has access to secrets. Yeah, so there are a lot of Kubernetes distributions you can choose from. You can do it the really, really hard way, like doing everything yourself, bootstrap, etcd. Unless you know what you're doing or want to learn, I wouldn't recommend it. So we at fairkom use K3s, which is just a really simple, lightweight, a single binary, like 100 megabytes or something, with everything we need for Kubernetes still. Right, so this is like perfect for us. We can still configure everything else, and for our customer at RLP, they don't have like that much know-how with Kubernetes themselves. So there's RKE2, which is the same. I think it's done by the same people that do K3s, OpenSUSE, if I'm not mistaken, which is like a full compliant Kubernetes distribution with everything you want. And there's also like a small. So this is like a difference, like the distributions themselves at RLP and ourselves. The storage, right? Because we use Ceph, which can be its own beast, can be it's really fast, scalable, does block file, object storage. But this is overkill if we have a Kubernetes cluster just for metrics, right? So Longhorn was good enough for a customer because it's a simple block storage, but it still does everything you want. Like for example, volume snapshots for backups, right? This is really nice. And also simple is not bad, right? If it's easier to maintain, and Ceph can be its own beast, right? So if you ever worked with Ceph and the whole stack. The deployment itself is nothing fancy. We don't use Helm charts, so I personally don't like Helm for, I don't know if it's obvious reasons, but we use Customize instead. So the thing with Helm is, if you ever just install it, you often don't know what's going to happen. You can Helm template it out and then deploy this, right, which is equivalent. Customize just works a bit different. You have a base structure usually, right, where you define all your stuff you're going to use a lot, and then on top you apply an overlay, a patch, and then you compile a big file, which is the manifest, and this you push into Kubernetes and you're done. But I can look into the file, see what's happening, can modify it. So this is what I like personally, and a colleague of mine. Yeah. So how the Synapse workers work, I don't think is too much magic, right? We have generic workers. We do generic stuff, which is just a deployment. We have specialized worker for the event persistence, for the media repo, stuff like this, which is a stateful set. We have the ingress paths from outside, right? With like the path selection going to each worker. We have the internal Kubernetes magic. Yeah, this is nothing too special, I think. We had some interesting challenges. Our customer had a problem with VMware because Broadcom bought VMware, and then there was some licensing issues. Maybe you heard about it, right? So basically, they asked us to maybe they can migrate the whole Matrix Schulchat stack to us, to our cluster, and then recently we moved back again when we fixed the infrastructure. But one thing we noticed it the longer the deployment lived, the longer the users were using metrics, the longer the volume mounts became, and that's the reason. Under the hood is just Linux. Containers is just Linux. So every time you mount a volume, so when you start a pod, right, you mount the volume in. The media store is like a few hundred gigabytes with like millions of smaller files. So every time this is happening, there's a recursive permission check through everything, right? So in the beginning, it wasn't that bad, like a few minutes. That's okay-ish, I guess. But the worst case I tested was like 90 minutes startup. So yeah, this doesn't work, but there's a nice thing you can set, the on root mismatch flag for the volume mount, which just says if the root folder, the top, has the correct permission, we don't check the rest, right? So this saved us like 90 minutes. The other thing is like the data migration itself was interesting. So the database was fine, right? This was like a single giant file. This we can copy over network. This is totally fine. But how are we going to deal with the huge media database itself, which is like millions of small files in subtrees and stuff like this? So the first thing I tried was just a kubectl copy. This turns out, interestingly, is just a tar command on the hood. You can only use kubectl copy if tar is installed in the pod or container you're using. And then you can maybe modify it a bit, right? So there's a listed incremental flag you can use with tar. So we can run a diff sync later and copy most of the stuff over like 2 weeks before, and then just the diff, right? Was really slow. also didn't delete stuff, right? So this was not the way to go. So what about rsync, right? You probably know rsync. Yeah, this also took like, I don't know, like 50 gigabytes in 12 hours, so not really worked. Because, of course, it's sequential and single-threaded, but we can throw more power onto it and make them use more cores with parallel. If you know parallel, this just forces them to run stuff in parallel. Yep, and that's the time. Sorry. So what we did is we have a small cache just for storage. We copy it over with parallel onto this, and then we split it up into like a lot of tar files. So it doesn't matter if like the VPN connection gets cut in between, right? We put all this stuff into RLP or back, and then we can just run the rsync over it again after we moved most of the data over, and then we just have the diff, right? So we could prepare it in advance and then only sync like the last 10 gigabytes that changed, or like deleted the files that changed in the media repo, right? And this was something that was interesting, challenging. There's probably a nicer solution, but this happens if you move from one Kubernetes cluster to a different one, right? From inside the Kubernetes cluster, this is an easy problem, but outside you have to deal with like the troubles you're having with different infrastructure. Yeah, and that's about it. Huge shout out to the people supporting us, who sponsored us, right? The Rhineland-Palatinate, Grille, and the FluffyChat community, which is based on, of course, metrics.
Thank you very much. Thank you, fairkom folk. Are there any questions from the room? Here we go. Would you mind passing?
Yeah, thank you for the talk. You mentioned that in the matrix rooms there must never be no admin, so you always need to have one admin in the room. How do you deal with situations where the admin, a user, gets deleted, like the teacher leaves the school, and then there are only pupils in the room?
Then
Yeah.
the room is set to read only.
Okay, so the room is only set to read only. Okay. How did you realize that?
Muss ich nochmal sagen.
Yeah, how we realize that? Maybe somebody can explain it better.
Just the microphone.
Yeah, you can explain it, or?
Yeah, okay. So how we notice it is we fell over it, right? So people reported it, right? So there was rooms who were in a troublesome state, let's say it like this. And then we had to make sure this could never happen, right? So we set it as read-only, and then maybe we can fix it later, or like have to talk to the admins to make sure whoever is going to take it over, right? So yeah, there was admin stuff involved. It wasn't that challenging. It was more like the organization stuff, getting this correctly.
Okay. Yeah. I want to ask you mentioned the configuration of permissions. Is that on the overall platform, is it something that's integrated in the messenger, or is it a dedicated application?
What exactly do you mean with permission path?
It was one of the screenshots earlier.
The communication matrix. Yeah.
It's implemented in the messenger, but only for like the org admin. So only the org admin of the school can access it within its messenger, and then he can, it's like in the menu, and then he can configure the communication metrics, but it's only for the role org admin.
Okay. One last question. You mentioned the IDM bot. Is that an actual bot that resides in each room, or is it more like something else?
Yes. So it's actually a user with admin access, and it's only in rooms where groups are. Like when you invite a school campus group or like a Bildungsportal group, then this user is in it and can modify the room. Yeah.
Okay, thank you.
Thank you so much.
Any other questions in the room? Yeah, here's one.
Did you think about upstreaming the changes to FluffyChat? Like, I think a PDF preview would be pretty cool.
Yes, we are constantly publishing the FluffyChat, and it's open source and available. But
yeah, we are in contact to maybe get some features upstream. Yeah.
Cool. Thank you.
Well, to answer that, I'm the Roland who didn't present where we had an issue, a legal issue with their CLA, and are just discussing this. Yeah.
I really enjoyed your talk. I found it interesting that a lot of the technical problems are essentially were done, and it's just an implementation matter. And now we're on to human things like the students need a PDF preview to make sure that they can't claim that they never saw the PDF. I think that's really interesting that we're now basically into the next stage of problems. Do you mind saying how large is the user base, or how many people are, like, what's your DAU, for example?
Yeah, at the moment we are in the pilot phase, so it's rolled out, and it's scalable for up to 500,000.
Gosh.
Right.
Okay.
Yeah, but at the moment it's less.
It's a pilot. Okay.
Yeah, it's a pilot at the moment. Yeah.
Okay. Last chance for questions before we say thank you to fairkom. No. Okay. Thank you very much.